Hi everybody, welcome back. This is Unit 8, Lesson 5, and we're in Section 3 of our Unit 8 notes, the Mathematics of Chemistry. And what we're going to talk about today is what a mole is. And while a mole is all of these things you see here on your screen, a mole is an animal that burrows in the ground. It's growth on one's body. And I think they even use the term mole or the phrase mole in like spy agencies, right? Isn't that somebody that turns on their government? That's not the context that we're going to use it in this class. We're going to use it in a different context. And so to introduce you to the context we're going to use it in here, I have a music video for you, because I know how much you all love these music videos. So here it is.
A mole is an animal that burrows in the ground, or a spot on your chin that you gotta shave around. But there's another kind of mole of interest to me. That's the kind of mole they use in chemistry. A mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend. Now say you had a mole of pennies to distribute around the world. Give to each of the 5 billion grown-ups, boys and girls. There wouldn't be a single soul down and out of luck, cause everybody in the world would get $1 trillion. Or say you had a mole of paper and stacked it toward the sky. Paper's double thin, but that pile would get so high you'd reach up into outer space. In fact, I think you'd find it'd go up to the moon and back 80 billion times. And a mole is a unit, have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend. Now suppose a mole of marshmallows fell upon the planet. Over each square inch of land and sea, you think that you could stand it? That layer would be 12 miles high and of course block out the sun. We're talking close to 5 million trillion tons. Well, maybe we could save ourselves if we all started eating 1 marshmallow each second. Not 2, because that'd be cheating. With 5 billion people munching, how long do you think it'd take? 40 million years, and that's without a bathroom break. And the mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend. Let's say you had a mole of atoms. Would the pile be immense? Should I say the answer now or leave you in suspense? Well, atoms are so very, very small, you understand. You can hold a mole of atoms in the palm of your hand. So shake a little sugar in the middle of your palm. Now you don't want to spill it, so try and stay calm. You hardly can imagine and barely realize there are more atoms in that sugar than stars up in the sky. And the mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend.
I know you'll be rewinding the video as soon as this is over so you could hear that song again. It's really a catchy tune. But what is a mole? Right? What is a mole? Do you know? Do you guys know in here? A mole is it's a unit. It's a unit. Just like dozen is a unit, right? A dozen means 12. A mole just means a lot more. So a mole is a unit that we use to count things that are really small. That we can't see. We can't even see them with a microscope. We use it to count particles or atoms or molecules. Okay? It's a made-up unit. Just like 1 dozen is 12, 1 mole is way bigger. 6 times 10 to the 23rd, right? It's that much. It's a lot. So if I had a mole of students, I'd be grading papers for eternity, right? 6 times 10 to the 23rd students is how many students I had. If you had a mole of money, you'd have 6 times 10 to the 23rd dollars. That would be lovely, right? So typically these things are very, we use them to count things that are very small. So if you had, I like the analogy about the marshmallows. If you had a mole of marshmallows, it would take 40 million years to get rid of them if we all ate 2 marshmallows a sec, or 1 marshmallow a second. But a mole of water you can hold in your hand. A sip of water is actually a mole of water. It contains 6 times 10 to the 23rd. It's about 18 milliliters of water. It's not very much at all. So we use this made-up unit called a mole, which, by the way, I didn't forget the E. It's abbreviated MOL. It contains 6 times 10 to the 23rd atoms or particles. That's what a mole is equivalent to. Okay? It is based on carbon-12, and we say it's the number of atoms in exactly 12 grams of carbon-12. So it's based on a carbon-12 standard. Why carbon-12? Because it's everything. It's in everything. We're carbon-based life forms. Carbon-12 is everywhere. So that's why they base it on 12. This number, the 6 times 10 to the 23rd, is Avogadro's number. And you will have to know how to interconvert between moles and molecules. Okay? So they're going to give you moles and ask you for molecules, and give you molecules and ask you for moles. Okay? So how can moles be converted to molecules? You'll multiply by Avogadro's number, 6 times 10 to the 23rd. Okay? We actually use 6.02, so we might as well write that down. We don't round like they did in the music video. Okay? So we will multiply by, whenever you go from moles, from ends in an M, the mathematical operation you're going to perform starts with an M. So when you're given moles and they ask for something else, you're going from moles. You will multiply, because multiply starts with an M. So if they give you moles, you're going to multiply by 6.02 times 10 to the 23rd. However, if they give you molecules and ask you for moles, then you're going toward moles. You're trying to find moles. And toward ends in a D, and the mathematical operation you're going to perform starts with a D. So if you're going toward moles, you're not going to multiply, you're going to divide. Okay? So if you're going toward moles, you'll divide by 6.02 times 10 to the 23rd. Now be careful. When you're dividing, you're going to need to put this number in parentheses. Okay? Otherwise, your calculator will divide by 6.02 and then take that answer and multiply by 10 to the 23rd. So you have to make sure that number is in parentheses. Okay? So for example, how many moles are there in 8.49 times 10 to the 23rd molecules? In this case, we are given 8.49 times 10 to the 23rd molecules. And they are asking us for how many moles? So in this problem, we're going toward moles. So you're going to divide by the magic molecule number, which is 6 times 10 to the 23rd. Okay? So in our calculator right now, we're going to type in 8.49 times 10 to the caret 23. Make sure there's parentheses around that number. And then you're going to divide it by 6.02 times 10 to the caret 23. Okay? Now, the nice thing, since we already learned sig figs, is when I'm dividing, I care about total number of sig figs that are given. This has 3 sig figs. So when I get my answer, I only have to place it in 3 sig figs. So we're going to divide, and you should come up with 1.41 as your answer. Okay? Look at number 2. How many molecules are there in 0.45 moles of nitrogen at STP? We are given 0.45 moles, and they are asking us for molecules. This time, we're going from moles. If we're going from moles, we will multiply by 6.02 times 10 to the 23rd. Okay, and again, it's not such a big deal when you're multiplying, but when you're dividing, you need your number in parentheses. So it's a good idea to get in the habit of putting it in parentheses. And again, I care about sig figs. This has 2 sig figs. So my answer, I will round to 2 sig figs. So you're going to get 2.7. Now in your calculator, it probably says something like this, 2.709E23. What that really means is, I'll round it to sig figs, 2.7. The E means times 10 to the 23rd. Okay? You could also set up proportions here. If you know 1 mole is 6 times 10 to the 23rd, 0.45 moles are how much? X, and then you would cross multiply to solve for your X. Or you can use dimensional analysis like we did in the beginning of the year. Watch this. I'm given 3.14 times 10 to the 25th molecules. The unit I want to get rid of goes on bottom, which is molecules. And the unit I want to convert to goes on top, which is moles. 1 mole is 6.02. That's your conversion factor. 1 mole is 6.02 times 10 to the 23rd. And if you remember, you would multiply by all the tops and divide by the bottoms. So really you're doing like what we did in example 1. You're going toward moles, so you are dividing. So you're going to take this number and divide it by that number because it's in the denominator. Again, put the parentheses around your whole numbers, and you should come up with, I need 3 sig figs, 52.2. All right, there's one example left here, example number 4. I'd like you to finish that example, please, for tomorrow. Any method you'd like. If you want to just do the from and the toward, or if you want to try to set it up dimensional analysis, that's fine too. If you'd also prefer to do a proportion, you can do a proportion too. I think that's it for today. I hope you enjoyed the music. It's kind of a catchy tune, and now I'll be singing it the rest of the day. Have a good night, everybody. We'll see you in class tomorrow.